You type 5 words. You press enter. And a second later, a painting appears. Not a stock photo, not a Google result. Something that has never existed before. A tiger made of stained glass, standing in a neon Tokyo street at 3 a.m. Or your grandmother's kitchen, but on Mars. Or literally anything your brain can describe. So, how does that actually work? Because from the outside, it looks like magic, and the real answer is somehow even stranger. Here's the thing about images and computers. For most of computing history, a computer could not make something it had never seen. If you wanted a picture of something, someone had to draw it, photograph it, or find it. Computers stored images. They didn't invent them. So when researchers started asking, what if a machine could generate something entirely new, just from a description that was a genuinely wild idea? Because language and images feel like completely different things. Words are abstract. Images are concrete. How do you get from one to the other? That's exactly what we're going to unpack. Here's the short version. The AI starts with random noise, basically visual static, and learns to gradually sculpt it into something real. In the next few minutes, we'll walk through exactly how that happens, step by step. First, let's talk about what the model learned before you typed anything. These image models were trained on hundreds of millions of image and caption pairs. A photo of a sunset, labeled Golden Sunset over the Ocean. A painting of a dog, labeled Impressionist Oil Painting of a Golden Retriever. Over and over. Hundreds of millions of times. And what the model built, buried in billions of tiny dials, just like we talked about in episode 4, was a map. A vast, invisible map of how words and images connect. What stormy looks like. What vintage feels like. How whimsical differs from dramatic. It didn't memorize those images. It absorbed the relationships. Now, here's the actual generation process, and it's called diffusion. Bear with me. It sounds technical, but the idea is beautiful. During training, the model was shown millions of images, and then it watched those images get deliberately destroyed. Pixel by pixel, random noise was added until each image became pure static, like watching a photograph dissolve into snow. Then the model was trained to reverse that process. Given a noisy, corrupted image, can you guess what was there before? Do it again, and again, backwards or through the noise, back to something recognizable. After enough of this, the model gets extraordinarily good at denoying, at pulling signal out of chaos. Now flip it around. You give the model pure random noise and a text prompt. It says, what image, starting from this static, would make sense for a tiger in a neon Tokyo street? And it runs the denoising process in reverse, step by step, guided by the words you gave it. 50 steps later, there's your tiger. But wait, how does the text actually guide the image? This is where it gets clever. Remember episode 1, where we talked about how language models learn to understand context? These image models borrow that exact machinery. Your text prompt gets processed the same way, turned into a dense mathematical representation of meaning, and throughout every step of the denoising process, that meaning acts like a compass. Every time the model asks, which way should this noisy pixel go? It checks the compass. Does this direction make the image more stormy? More neon? More impressionist? The text doesn't describe the image. It steers the generation, constantly, from noise to clarity. Now, full honesty moment. These models are extraordinary, but they have real blind spots. Hands are notoriously difficult. Fingers multiply, bend wrong, fuse together. Text and images almost always comes out garbled. Very specific spatial relationships. The red ball is behind the blue cube. Often get muddled. Why? Because the model learned from the pattern of pixels that tend to appear near certain words. It never learned physics. It never learned that hands have exactly 5 fingers. It learned that hands look approximately like this. And sometimes approximately isn't close enough. It's the same core issue as language models hallucinating facts. The model is confident. The model is pattern matching. The model is occasionally completely wrong. So what does this mean for you? Image generation is genuinely useful for anyone who needs visuals but can't draw, can't afford a designer, or just needs to move fast. Marketing materials. Thumbnails, yes, we use it too. Concept sketches, illustrations for presentations. The practical rule: use it for drafts, mood, and speed. Don't rely on it for precision. Precise details, accurate text, or exact compositions will need human finishing. And artistically, think of it less as the AI makes art and more as you direct it. Your prompt is your creative vision. The model is your incredibly fast, occasionally unhinged collaborator. The more specific your prompt, the closer it gets to what you imagined. That's actually a skill worth developing. So, random noise, text as a compass, and 50 steps of guided denoising. That's how a tiger ends up standing in a neon Tokyo street at 3 a.m. Not magic, just a model that learned to sculpt chaos into meaning. Next time, we're asking, how does AI actually understand what you're feeling? Not what you say, what you mean underneath it. Sentiment analysis, tone detection, and why machines are getting surprisingly good at reading the room. Subscribe so you don't miss it, and we'll see you in the next one.